All right, year two, this is 17E. We're going to talk about independent events. We can find the probability um, of different events, so probability A, probability B, using intersection, union of those events in those previous lessons, probability of A given B or B given A. But to find the probability of conditional probabilities can be hard to do unless the probabilities of A and B don't affect each other. And that means they have to be independent. So if they're independent, they won't actually interact with each other. And that means that knowing the probability of B will have no impact on the probability of A occurring. So what they're saying is that the probability of A, given the fact that you chose B already, is the same thing as just the probability of A. So each time you want to talk about the probability of A, if they have no bearing on each other, then it's just the probability of A just happening. And same thing with B. And so they're saying that since the probability of A intersecting B is the probability of A given B times the probability of B. And if probability of A given B is just the probability of A, they come up with this formula that if they're independent events, if. So this is one way we're going to be able to test if things are independent, is that the intersection of A and B probability is the same thing as the probability of A times the probability of B. So there's going to be times where they're going to tell you they are independent, and then there are going to be times where they're going to say, hey, are they independent? So there are two different types of questions. So if it's telling you you're independent, you can use this equation here. And if it's asking are they independent, you use the equation to show that these two sides are the same. So we only have two examples. The probability of A in this problem is 0.5. The probability of B is 0.2. The probability of the union, togetherness, is 0.6. Are the points A, or events A and B independent? Now, notice that it's using the union and not the intersection. So you have to use the formula they have here from last lesson that says that the union is the probability of A plus the probability of B minus one of the intersections. And you got to solve for the intersection. And if you do that, because they gave you all the numbers here, so 0.6 equals 0.5 plus 0.2 minus the probability of the intersection. And so they found out the intersection is 0.1. So that means you should be able to verify that probability of A, which is 0.5, times the probability of B, which is 0.2. Multiply those two together, you better get 0.1 because that's what the intersection is. And so, since that is true, they are independent events. So, it's easy, but it can be confusing on how you should be setting it up. So be careful on how you watch that. So if you do know that, that's when this problem comes up, where A and B are independent events, where the union is 0.8 and probability of A is 0.2, find probability of B. Again, you will use this equation for the union, probability of unions. So you're going to stick them together and plug in, again, what you know. You know 0.2 is A. You know that 0.8 is the intersection, or the union, sorry. And so you have to use the fact that the intersection is just multiplying the probability A times probability B. So they make a little leap here from this step to this step, but the probability of A intersecting B is the probability of A times the probability of B. So they took the formula that we had here and they just supplanted or substituted the probability A, probability B in there. And so when you do that, you end up having some PBs minus 0.2 PB, which is 0.8 PB, probability B. And so when you swing this over, 0.6, divide it out, you end up with 3/4 or 0.75. So that is the two different ways that we'll be using your problem here. Have a great day. Good luck.